Okay, let's continue now with slide 36, looking at the this artificial situation where you set up a muscle in a stress detector with a chart recorder or a screen, and you have a stimulator. And here we have muscle tension on the y-axis, which is strength. How strong is the contraction? Voltage increments down below. So you have this electrode stuck in the muscle, and down here you give 1 volt, 2 volt, and that's subthreshold. You're not firing any motor units. Finally, here you've raised threshold enough in some of the muscle fibers to get a little bit of tension, and then you do more and more and more stimulus intensity. You get higher and higher contractions until you reach a maximum contraction. Why is it that if you don't give like about 6.5, you get a maximal. You give 7.5, you give 8, 8.5, doesn't change. At this point, you are firing every single every single fiber in the muscle. All motor units are firing, and so now it doesn't matter whether you uh, get a higher and higher stimulus intensity. You're not going to get any greater contraction. So slide 37, contraction strength is variable because twitches summate, even in one single. Now we're looking at a twitch, we're looking at one muscle cell. Um, and, um, and we're going to look at something called individual twitches, and then what's called TREP, where they start to summate. And then incomplete tetany, where they summate more, and then tetany when they're maximal sustained contraction. They don't relax at all. Tetany is not really seen in the body. Like I said, this is an artificial thing we're setting up. Um, Sustaining contractions is achieved by contracting different motor units in an overlapping pattern. So if you want to hold something heavy in your hand for a long time, you're using this like 10 motor units, and then all of a sudden you switch over to a different 10 motor units. And then a little bit you switch over to another different 10. It's because those motor units are um, fatiguing, and your body automatically does this. Okay. Oftentimes, the strength of the contraction really depends upon the amount of calcium present. Because if you stimulate the cell before it relaxes, there's still some calcium in the cell, and so the resulting contraction is greater because there's more calcium present. Also, the strength of uh, the tension generated is really also a function of the length of the muscle fiber. And we'll see this in a later slides called the uh, um, strength length relationship. That muscle contracts best when it's at a particular length. Here are chart records starting with twitch. So you twitch it and the frequency is low, and you let the muscle fiber relax completely before you stimulate again, and they're all the same size. However, if you don't let them stimulate all the way, you stimulate it again before it's relaxed, then you'll get this increasing higher and higher tension generation because the twitches are summating. And here is where you increase the frequency continuously, and you get a wave summation. You get what's called incomplete tetany, and right here is tetany. You're firing this cell as fast as you can, and it doesn't even relax, and it will fatigue very rapidly when that happens. What does contraction strength depend upon? As I mentioned, it depends upon the strength of the stimulus, and upon the frequency of the stimulus. But it also depends upon temperature. Warm muscles generate more tension than cold muscles. A lower pH will cause a stronger contraction than a higher pH. In a state of hydration, if the muscle is really dehydrated, it won't generate as much tension. Stimulus intensity, remember, recruits motor units. The higher the stimulus intensity, the more motor units are developed, and over the whole muscle, then the greater tension. Stimulus frequency is really individual muscle fiber. You depends on how often you stimulate individual muscle fiber. You call summation, and it goes TREP or incomplete tension. Muscle tone. Involuntary contractions of random motor units when the muscles are relaxed. So even when the muscle is completely relaxed, it generates a little bit of tension, burns a little bit of ATP, even though the bone is not moving. And this is to get it ready to be instantly used. And it's a motor program from your cerebellum that comes down there and automatically keeps. And that's what happens when people have spinal cord transects. They lose muscle tone, and their muscles atrophy. Um, the contractions don't move muscle; they move bone. Stretch. Uh, Muscles are like elastic bands, and you want to keep them stretched and just ready for instant use. And this is what muscle tone is for. And also, there's really a trophic relationship between the nervous system and muscle. Muscle stays healthy if it's stimulated regularly, and it completely atrophies if it doesn't. And finally, there are two types of really contractions: isometric contractions, isotonic contractions. Isometric means same length, changing tension. Isotonic means changing length, same tension. So if you want to move something immovable, this will be an isometric contraction. The muscle changes tension, gets stronger and stronger and stronger, trying to move this thing, but it doesn't get shorter. Isotonic is what usually happens. It's changing length, same tension. You need a certain amount of tension to lift an object. You get that tension and you pull it up and your muscle shortens.